Light emitting diode LED.
Okay, after learning about the optical detectors, let's learn about those optical uh, emitters or optical sources, LED. So what's happening is today, if you go to a supermarket or if you go to Bunnings, they sell LED lights, and you can buy cheap LED lights to put it in your house. No, they're not really cheap. They are energy efficient. Okay? Yep. So the use of LED in everyday housing is happened just only in recent 20 years. Okay. Before that, okay, we use LED only for uh, practically only for photonics purpose, okay, transmitting signals. So here is a sample of LED. Okay. It looks like a normal dot with arrows pointing outward. Okay. It emits light. That's why the arrow is outward. So uh, the property graph of the LED looks like this. Okay. So normally, okay, uh, it's normally the LED has a sharp vertical lines there. They not theoretically it's a sharp vertical line, but in reality sometimes it's curved. For instance, this part is curved. The idea for LED is LED lights can only be either turned on or off. Okay. So LED lights cannot be, uh, say, you buy those well, at your house, maybe you have a good lamp. Sometimes, sorry, a light. Sometimes you turn the switch around, the light become brighter or dimmer. You can just, we can adjust the brightness of the globe. However, it never happens with LED lights. Okay? Uh, for LED lights, for a globe, for one LED light, it's either on or off. We just cannot adjust it. Okay? So that's why it has a sharp vertical line. So the idea is if you look at this graph, now have a look at this part here. Okay? Have a look at the current. Okay? For this particular LED, the operating current is about say 6 milliamps. So when the current is equal to or above or greater than 6 milliamps, the LED light turns up and it consumes a voltage of 1.7 volt, regardless what's the input uh, current. Okay, so that's the property of LED lights. Now, have a let's do some questions. Just get familiar with it. Okay. Question one is always a simple question. Describe the basic purpose of a LED light. Okay. So light emitting diodes. Well, I think by this stage you should be able to do that question. LED lights basically converts electrical energy to light energy, or converts electrical signals into into signals in light form. Okay, so that's the purpose of that's what does LED do. Okay, now let's go to the next page. Now have a look at this question. Okay, so in this question we have an LED light, okay, constructed in series with a resistor, and I need to find actually yep, okay, now I need to find the current in the circuit when the voltage, okay, here is 4.5 volt. Okay, now let's do it. Okay, we have a yep, when the input voltage is 4.5, I need to find the current. Okay, so if you look at now Yeah, I gave you a few seconds to think about it or have a read about it. You can pause the video and try to do it by yourself. Okay, now I'm going to do this question. The input voltage is 4.5 watt. Okay, and it's connected in series. So the total of 4.5 watt is going to be shared between the resistor, the 100 ohm resistor, and the LED lights. Okay. Now have a look at the LED lights. Okay. The operating voltage of the LED light is going to be 2 watt. So when electricity travels through the circuit, okay, the LED light is consumed 2 watt. Okay. Simple subtraction. So the other 2.5 watt must be consumed by the resistor. Okay. Now consider only this resistor here. Okay. The current is going to be V divided by the resistance. Okay. The current of this, the voltage of the 100 ohm resistor is going to be 2.5, and divided by the resistance, the value is going to be 0.025 amps. Put it in milliamps, it's going to be 25 milliamps. Okay. And we can say 25 milliamps is well above the minimum operating current of the LED. So the LED lights up, and the current is going to be 25 milliamps of the whole circuit. Okay. Now, yep. Yeah, the calculation is basically similar to what's happened with a normal diode. Okay, now let me just show you another example. Now we have, in this case, we have an LED, and in this, well, in the graph, the LED is not really sharp. Okay, now the question asks me, okay, the current measured by the ammeter is 10 milliamps. Okay, what is the value of the resistor R here? Okay, now, yeah, I gave you a few, you can pause the video. So I'm going to do the question now. I'm going to show you the answer now. Okay, now the current is 10 milliamps. We go through the property of the LED. We read from the graph. Okay, now when the current is 10 milliamps, the LED must be operating at 1 watt. So the LED is operating at 1 watt, and totally there will be 6 watt. So what's happened is, the other 5 watt is going to be used by the resistor. Okay, so we need to find the resistor here. Use the equation. We know the current because it's a series circuit. The current doesn't change. It's going to be 0.0. Be careful with the unit. It's 10 million volts. Okay, 0.01 amp. Sorry, milliamps. Now we know the current. We know the voltage across the resistor. Then I can find the value of the resistor. Okay. V equals to IR. The resistors equals to voltage divided by the current. It's 5 divided by 0.01. Do your math, it's going to be 500 ohms. Yep. Okay, now have a look at another question. Okay. This time we have a much better LED. You see the line is sharp. Well, the line is really steep. It's a vertical line. Now we have a circuit, and they ask me the current through the LED. Like basically the current of the whole circuit. Now let's have a look at the operating voltage of the LED. the LED is operating at 2.5 watt. Okay, so, yep, the power source has 8 volts, so 8 volts must be shared between the resistor, the 300 ohm resistor and the LED. So the 300 ohm resistor must have 8 take away 2.5, which equals to 5.5 watt, okay, across the 300 ohm resistor. And I need to find the current. So V equals to IR. My V use the voltage of the 300 ohm resistor. The current will be V divided by R. Okay. The voltage is going to be 5.5 volt. Okay. Of the 300 ohm resistor, the resistance is going to be 300. Do your math, you'll find your current, okay, through the whole circuit, of course, through the LED. Okay. Now, yep. This question is a past year exam question. Okay. We have 6 LED lights. 3 of them are connected in series, and the other 3 is connected in series. Both set, each 3 of them are connected in parallel. Okay, so the operating voltage of the LED light is 3 volts here. So the LED lights are connected in the right order, means the current coming in and travel through them. Okay, so they should be all operating. So in this case, okay, so in this case, now each one is 3 volt. Just let's write it down. And since 3 of them are connected in series, we should combine them together. Okay. They use 9 volt. Okay. We combine this side, it use 9 volt. Okay. And these 2 sets of LED lights are connecting in parallel because current here splits up to both sides simultaneously, so they are in parallel. Okay. And the combination of this parallel is going to be 9 volts, okay, because when components connect in parallel must operate at the same voltage. Okay, now we need to find the current through resistor 2 here. So we have 9 volts here, and the resistor is connected in parallel, in series with this whole set, the whole 6 LED lights. Okay, so we have totally 12 volt. We have 9 volts here, so the resistor must have 3 volts because 3 plus 9 is going to be 12. Now, use our equation V equals to IR, okay, because now the current will be V divided by R. Okay, now we use, okay, because we're interested in the current through resistor 2. Okay, so the total current here. So we use resistor 2. So the voltage across resistor 2 will be 3, not 12. It's 3 divided by 60. Do your math, it's going to be 0.05 amps, and that's your answer. Now the next question says, okay, we have the same LED lights, however the arrangement is different. So what's happening is the second LED lights are reversed biased. Okay, now let's have a look what's happened there. Okay, when the current comes through here, when the current then splits up, okay, the current goes to this direction and goes to this direction. Okay, however, I name it I1 and I2. Okay, so I1 is quite well, it travels happily through every LED lights and finally reaches the negative terminal. However, if we look at I2, now I2 is able to travel through LED lights 1. However, when it comes to LED 2 is in reversed biased. It cannot travel through. So what's happened is the circuit breaks. Okay? Means current doesn't travel through. So what's happened is it's just equivalent to this. Okay? Now, just remember, just clear something, just to make it clear. Okay, the only diodes we learned can operate in the reversed biased position is the photodiode. Okay, this week. Okay, so are there any diode in the reverse biased position would result open circuit. Okay, the circuit would open. So basically, yep, the current doesn't even split up because it cannot travel through. So if I look at that, LED 1, 2, 3 will be off. Okay. And LED 4, 5, 6 will be on. Because current is happily traveled through it. Now, yep,